It is coursework and examination, and coursework is 40%. So, and it's quite hard, because what we realize that you learn more with the coursework, and there will be 2 coursework in this module, and examination at the end. So, why are we running this course? What is the reason behind it? So, as you see here in this graph, what's happening to our population is increasing, energy consumption, and as well as the temperature. And what we are doing is looking at the renewable energy sources. So what we will be doing in this module is to learn about renewable energy sources in the context of geotechnical engineering. Okay, so how we do the geotechnical engineering design for renewable energy sources. So such as offshore wind turbine, carbon sequestration, nuclear power stations, though it's not renewable, but it's still questionable, but still it's a good energy source because it doesn't cause carbon emission or greenhouse gas emission. So we need to, as you can see, the population is increasing, energy demand is continuously increasing, and we will need new energy sources to meet this demand. Then again a cartoon here. So what's happening is that, yes, again it's emphasizing the same thing. The population is increasing, our energy requirement is increasing, the food requirement, and all that increasing. As you can see, that we will need 40% more energy by 2030. Okay, and one thing is that we won't be able to get rid of fossil fuels so easily. It will take some time. It's not that we can cut off fossil fuel energy today and use renewable energy. We cannot do that. We will still need fossil fuel energy. So that's why in this module we are covering carbon sequestration, that we can still burn fossil fuels but catch the carbon and put it in the ground. Okay? So you will be learning about that. And then urbanization. You can see this is from I think it's from Brazil, favelas, and as you can see, the people are moving from countryside to the city centers, to city for the jobs. So there is a lot of pressure on our cities, and again to ease that pressure in terms of energy, how we do that? It's very challenging. How to provide clean energy, water is very all the countries in the world facing this challenge at this moment. We can look anywhere, and the pollution. If you go to central London, you can see. If you travel through London Tube, you will realize that the London Tube is the most polluted place in the country. So why it's happening? Because population is continuously increasing and putting a lot of pressure on our cities. We cannot stop that. If you think we can stop that, no, that's not going to happen. So we need to find a solution, because we cannot say people, oh, you go back to the countryside and do farming as you were doing it, because people are looking for new things, new jobs, and nowadays jobs are driven by technology. Okay. So here, just again about energy. So what we are doing is to emphasizing that the energy use, because this module is all about energy. That's why it's called energy geotechnics. And you can see the energy use at this moment where we are. And as I was saying that, okay, we are moving towards renewable energy, but it cannot phase out the fossil fuel completely. It will happen in phases. And this is the currently it's you can see the distribution, how we are using it. Still big chunk of energy is coming from oil, coal and gas, and that's predicted as well by 2030 still we will be using that, because as you know, renewable energy, they are not cheap, they are expensive. So now we cannot go to India or China and tell them, listen, you guys are going to use renewable energy from tomorrow. That's not going to happen because it's very expensive, they cannot afford. So they will be still using fossil fuel. And another thing, the fossil fuel energy is very consistent. Renewable energy, that let's say solar panels, they work when you have sun. So you don't get energy continuously. But offshore wind turbine is now almost beating that challenge as well. Because with offshore wind turbine, we can get the energy almost throughout the day. And we don't need a lot of wind power. Subi would be covering that that part, offshore wind turbine, how to design that, how to design the foundation of offshore wind turbine. So this model is basically covering, how to deal with present energy use, how to, if we're still using fossil fuels, so we're still emitting carbon emission, how we can sort that out, and also looking at the renewable sources such as wind and nuclear power. Okay, though nuclear power is not renewable, but it doesn't cause pollution, carbon emission. Okay, so this slide is more or less what I am trying to say is that yes, we need more. So just telling you the type of energy we have at this moment. Here is, which I didn't talk about, the geothermal energy. So in geothermal energy, what we'll be covering is that using the ground energy for heating and cooling the buildings. So this module actually will be taught by Subi and myself, and there will be 2 more lecturers coming, because it's very diversified module, and we recognize that we cannot cover all, one person cannot cover all these topics. Okay. So coming to the module content, so what we'll be covering in this module and who will be covering it. So first 3, so wind turbines, offshore wind turbines, then is offshore oil and gas installation and nuclear power foundation. So these 3 topics will be covered by Subi, and he will be taking next 2 weeks, so 3 weeks basically, including today. He will be trying to cover all that in his 3 weeks time slot. Then I will be covering 2 topics. One is on energy pipe using the ground energy, geothermal, and then on nuclear waste disposal. Because with nuclear power plants, what happens? That we generate a lot of waste. How we can dispose it safely. Then we will have carbon sequestration, which will be covered by Mojgan. She is from Imperial College London, so she will be coming here and taking 2 lectures. And the last one is on methane hydrates and compressed air energy storage. So that would be covered by Liang. So have you heard of this methane hydrates? What is methane hydrates? Any idea? Give it a go.
Is it gas like crystals?
So methane trapped in ice at the bottom of the sea, and people are planning to use that methane. Okay. And then compressed air energy storage. Anyone? Have you heard of that? As you were discussing that the renewable energy problem is that they are not available throughout the day. However, offshore wind turbine is beating that. So the challenge is to store the energy. So when we have the energy, we get that energy and store it to use it at another time. So let's say we have solar panel, we generate energy in the afternoon, we store it somewhere, and then we can use it in the night when we come home. And that can be done by using compressed air. So what you do is to put the compressed air underground. So pump that, and then you release it again to move the turbines. So that would be covered by Leanne in the last lecture. So this is Fukushima. I think so we will talk about it. That's his area.
We will talk about this.
So you want to say something?
What happened is that after this Fukushima accident, if you remember in 2011, 11th March, after that, a nuclear power plant became quite a risky business. So many countries are trying to decommission. They are not having faith in that because you leave something for many, many years, 10,000 years, because this waste can, degrade and decompose and release things. So what I will do, I will take into account why this particular foundation failed, why the nuclear power plant failed, and what can be done, what are the critical points. So during my course on this particular topic, I will cover some aspects of that, just to give you, make you aware of this energy whole challenges, what are the main things, why people are thinking about different options. So those things.
Okay. So this is about nuclear waste repository. So as I said, that nuclear power plant generates a lot of waste, and it's very high level waste. You cannot dispose it on the ground or in the landfill. It has to be disposed properly. And this is a schematic of nuclear waste repository. So what we do with high level waste, we dispose it under the ground at a depth of kilometer or deeper. And it is put it in a geological formation, basically rock formation. And if you see, so these are the tunnels basically where the waste is kept. And if you look at the enlarged view, that's how it looks like. So this is the nuclear waste put in the canister. And these canisters are generally made up of steel or copper. And then these canisters are surrounded by clay liner. So do you understand what is clay, what is sand, what is clay? Tell me. Or have you seen sand and clay? So where is sand? Where do you find the sand? On the beach. And clay is when you, let's say, go to countryside and your car gets stuck in the mud, that is most likely to be clay. Clay is very sticky substance, sticky soil. So with sand what happens, when you put the water, it drains out very easily. But with the clay, it's not. You put the water, water will take ages to come out. And that creates, consolidation problem. And if you know, Leaning Tower Pisa was leaning because it was on very soft clay. That clay was compressing slowly as the water was coming out. Okay. So just one quick question. All of you are civil engineers?
Yes.
Anyone who is not civil engineer here?
I'm geologist. Okay.
So, but it's still, yeah. And what about you? You are? You're engineering geologist. And who else? Okay. So you will understand it. So,
Yes, sir.
Yeah, geologist.
so you should not have any problem understanding. So you are aware of rock and soils and yeah. So basically this is a clay liner and it's a swelling clay liner. So clay swells. So clay is also of two types, swelling and non-swelling. So when you put the water in swelling clay, it will expand. And it can expand by almost double or triple, depending upon the type of swelling clay and what minerals are there. So one thing, if you're building a house on a site, let's say you are building a house for yourself on a site. So you want to make sure that you don't have swelling clay at that site. Because what will happen, if you have a swelling clay at that site, and if rain comes, that clay will expand. And if you have put a lot of money in your house, building there, what will happen? It will crumble. You will have cracks and, as I said, clay can swell by almost 200%, 300%. So if your room was, let's say, on the ground floor, that can go by half a meter or 1 meter. Okay? So you don't want to construct anything on swelling clay. But swelling clay is good in one sense that it's very impermeable. So let's say if I put water on this table, water can go through this table only if there are air voids, if there are voids, okay? If there are no voids, it won't pass through. And that's what happens with swelling plate. So when it swells, it gets rid of its voids and become almost impermeable, which is very good for repositories, that it won't allow any radionuclides to pass through the system. Okay. So I will be covering all that, how to design this, how do we select the material and all that, so I will be covering in this topic. Then offshore wind farms, that will be covered by Subi. Do you want to say anything here?
No, we'll have to talk
You
about
will
it
do
after.
it. Okay. So Subi will cover this. Then again, this will be covered by Subi. You want to mention anything here? The size?
I will cover it.
You will cover all
Yeah.
that, okay, today.
Will you
Subi-
touch on the installation of cables as well?
Yeah.
So Subi will cover the foundations, yes, of offshore wind turbines and nuclear power plant. Okay.
And oil and gas as well.
And oil and gas.
Yes.
Cover that. So this is again, so he will have all these photos in his later presentation because I am going to leave you